Which is the same as what you have already switched it on. All right. What we are saying is we are looking at the arc length and then the angular speed. You have to recall this. So you have to recall that 1 degree is equal to pi over 180 radians. All right. You can find 2 degrees, 5 degrees, something like that, right? So 1 degree is equal to pi over 108 radians. Therefore, what about 1 radian? One radian. So if you are to calculate 1 radian, all right, 1 radian is equal to 108 over pi. So 1 radian. So 1 radian. So 1 radian is equal to 180 over pi degrees. All right. So you have to recall that this. So this issue of radians and degrees, we'll be talking of them frequently, especially when we are looking at even up to the whole of the course. Now, the issue here is that let's now find out. Let's look at the arc length and then the angular speed. Having known that 1 degree is equal to pi over 180 radians and 1 radian is equal to 108 over pi degrees, you have to take that in mind. All right. So we are now using a circle with radius r, and then the length s of the arc. Want to look at the arc length, which is subtended by a central angle by theta. Let's come up with that. Then wanted to look at that. By definition, if you want to define what is an arc length, if you look at an arc length, it is that a central angle of a unit, which of course part of the central angle for a central angle of a unit circle. That is what is called an arc length. An arc length. So, in other words, it is just a fraction of the circle circumference or perimeter that is being subtended by the theta. Now let's go to let's look at this formula of how do we calculate that arc length. All right, how do you calculate the length of the arc length given radius and then the central angle? So let's look at that. Calculation of the radians. All right. Given a circle with the radius r, all right, if you are given that circle with the radius r, and then the length is, all right, of an arc subtended by the central angle of the arc subtended by the central angle. All right, subtended by the central angle. Let's think that this angle is the theta. All right. Now this statement here, which is there, all right, this statement there, it is it can be given by diagrammatically. What is happening there? It is this diagram here. All right, it is that diagram where you have got the two cycles. I think we have to look at that. So this is the center here. If you look at the center up to there, from the center, this is our arrow. All right. If you look at that center up to anywhere, up to especially this center up to here, this is our radius. So this is our arrow. Assuming that this is our arrow, we are stopping at there. All right. So that is our arrow. And then if we take another position going this way, take any position going, assuming that this line it goes like that, the angle that we are interested here, this angle is the theta. So this angle is the theta. And then according to this statement, given a circle with radius r here, and the length s of an arc. So the length s there, what they are talking about, that length s, it is this one. The length s they are talking about there, it is from the one that is being subtended, it is from this. So this is our S, and this is the arc. This is the arc subtended by the central angle, which is the theta. If you look at this one, what is happening there? This is just a fraction of the whole circle. It's a fraction. You know, a circle has got 360 degrees, right? And 360, it is the same as 2 pi. You know that, right? Because 1 pi is 180. All right? 1 pi is 180. True or false? All right. 1 pi is equal to 108. 2 pi is equal to 360, right? Therefore, if you look at this, what is happening here? The angle that is being subtended, this is, if you look at this, it's a fraction, right? It's a theta over the whole of which is 2 pi, right? Moment, wait. So, S, want to find this one, is equal to, this one is theta over 2 pi. In other words, theta over 360. Because if you want to find this one, it's the same as theta over 360. All right? But 1 pi is 180. 1 pi, that's why we are saying that the fraction, what is happening here? Only this part is a fraction of the whole of the circle, right? So that is the theta over that. Okay? Now, when you look at theta, this is the fraction of that, right? And if you look at perimeter of a circle, all right? Let's go to perimeter of a circle. If you look at perimeter of a circle, or in other words, the circumference of a circle. What is the circumference of the circle? Circumference of the circle is equal to 2 pi r. Okay, very good. Or the same as, which is the same as 2 times diameter, right? Pi times what? Diameter. You know that, right? Which is the same as this. All right? This is for the. So I wanted to find out what is this fraction here. If we are looking at this fraction as comparing to the this is because the distance around from here up to this one is the what is called the perimeter. All right, perimeter is the circumference of the circle. You know that, right? Perimeter is the circumference of the circle, right? Clear? Perimeter is the distance around any circular object. Clear? Anything from any circular object, that is what is called perimeter. Now, if you look at what is happening here, all right, wanted to look at what will be the perimeter of this one in relationship to this angle here. All right, so the perimeter of the whole of this one in relationship to that one, what it means there is we are taking this one as a fraction multiplied by 2 pi r, which is in other words, you're multiplying by the whole perimeter, because this is the perimeter around the circular object. But this is just a part of that one. So I wanted to relate what is this in terms of the perimeter of that. All right. Now, when you look at this one, what is happening there? If you look at this one, you will discover that this and that one will cancel. All right? What is remaining there is what? Theta times what? Theta times r. All right? Which is the same as r what? R theta. Therefore, this part here, this part, it is this one, which is r what? R theta. All right? So, first step is, what we are saying is that the distance around anything is a perimeter. All right? And then, this one, if you relate to this one, this is it is just theta. It's just theta over 2 pi. It's just a part of the circle. Part of the circle is this one. Theta over what? Over 360. Assuming this is 4, it will be 4 over 360 to find what is this fraction. All right? Then it will be theta over it will be theta over 2 pi. It's a fraction. But we know, we wanted to relate this theta over that, this one, we wanted to relate this theta over 2 pi to the perimeter of the whole of this one. So the perimeter is, what you are saying is 2 pi r. So when you multiply this one by 2 pi r, this and this one will cancel. What remains there is r theta. So therefore, that r theta, it is the arc length. In other words, is the arc length S subtended by the central angle S is given by r theta. Therefore, this now it holds that the arc length of S subtended by the angle theta as portion of the circle is given by r theta, like that. Right. Let's look at an example. Go to, open on page 468. Open the page 468. Let's apply the formula. Therefore, the formula for arc length is this one. So this is the formula for arc length. This is the formula for arc length. Formula for arc length. So the formula for arc length is this one. Go to an example. Let's look at an example. Example number 3. The Galapagos Island lies almost exactly on the equator and are located 90 degrees west longitude. Suppose a ship sails along the equator from the Galapagos to the international date line at 180 longitude. How far does the ship travel? Assume the Earth radius is 6,370 kilometers. So let's apply this formula, the r theta. So they are saying that the Galapagos Island is almost exactly on the equator, 0 degrees, and are located 90 degrees west longitude. If you look at that diagram there, there is that 90 degrees, right? From the Galapagos to the international date line. So you can see that there is international date line, which is 180 degrees. So how far does the ship travel? Assume the Earth radius is 6,370 kilometers. All right? Now, if you look at what is happening there, the critical observation is that the ship travels 1/4. So the ship will travel 1/4 of the Earth's circumference from 90 degrees west to 0 degrees longitude to of 0 degree longitude to 180 from 0. So the angle at the center of the Earth described by the ship is pi over 90. So in other words, when you look at this one, what they're trying to say is that this 90 degrees, the 90 degrees, that this is almost 90 degrees west longitude. If we convert that degrees You see, 90, because 180 is pi, right? Right? 180 is pi, eh? All right? Want to use this formula here. Our formula is this one. All right? Now, pi is equal to 100 what? 180 degrees. All right? What about 90 degrees? 90 degrees is equal to more or less? Less. So if it is less, 90 over 100 what? 80 times what? Pi. All right? Then the answer will be, so, meridians, right? So meridians, these are radians. Eh? Is it? Yeah? All right. So these are radians. Now, when you look at this one, this gives you one and this goes 2, right? So what does that mean? It is pi over what? Pi over 2. So this pi over 2 is equivalent to 90 what? 90 degrees. You know that, right? Zero is the radius. So I show you that now the radius is equal to what? 637 what? 0 what? Kilometers. Huh? Are those kilometers? Yes. Yeah, kilometers. Kilometer. This is the radius. I show you this is the radius. So how do we calculate the arc length? So arc length is equal to right r heat. Alright? So this is what is our r? Pi over what? 2 multiplied by what? 637 what? 0. Alright? Like this, right? So this gives you this one, right? And then goes what? 3, 1, 79, 8, 8, 16, 1, 5. Right? So this is 3, 1, 8, 5, 5. That is it. Are we? Is it? Look, yeah, something like this. 31855. Alright? But now, if we look at 3155, alright? 31855. What is 1 pi? Pi is unrelated. Yes. So, this is 3185 multiplied by 18. Can you find out from there? What is that? What? 573,573, 300. Like this. Hmm? Are you sure? Are you sure? Are you sure? Are you sure? Nice. this correct? 6370. Is that one 6370?
6370.
Alright. Multiply by pi over 2, right? So our h, the array is equal to this one multiplied by pi over 2, right? So when multiply by pi over 2, which is the same as 2 here is 3, alright? 3 here 1, 8, 16, 1, 5, this one, alright? So this is 3, 1, 8, 5 multiplied by what? Pi. Multiplied by pi. How do you do that? What is that?
Name is 10,005.
Ya benar saya nas. Ya?
Yeah, that is 5. What is 1?
Huh?
What is 5?
What is
What is
What is pi? What is okay? So it gives what? 10,000
and 5.
10,000 like this.
Yes. 0.97.
0.97. Alright? 0.97, right? Alright. When you take this one apply directly to pi,
Yes.
you without multiplying by 180. If you multiply by 180,
The first one
is giving you another answer.
is
What is it giving you?
573,000.
Huh?
573,000.
Okay. Multiply by 5 is giving you
10,000. When you multiply by
180.
it is 573,000.
So I think the basic thing is you have to multiply by 5. So because when you multiply by 5, you have to find you know that the acronym is what they want is something like do this. The acronym what they want to find the distance from here. You know that, right? Hey, where the distance the acronym is equal to r theta, the formula. All right? Clear? Now when you look at this one, this is in kilo. Because in kilo they want to find the distance of the acronym. The acronym is the distance. Clear? Is that it? Okay. Okay. All right. Can you try doing the same? Multiply by pi is 22%, you know that, right? Okay. Can you multiply 3,185 multiplied by 22 divided by 7? Do that. Let's try this. If we know that pi is 22%, let's find out. What is it?
10,010.
Huh? 10,000 and what? And 10,000. And 10, yeah. I think it is just close to this, right? So if when you do this one, it's correct. If you divide by 5, it's correct. Right? But what I want is the 10,000 there. Alright? That difference of 10, they can know that the error is not right. So when you multiply by pi, you're giving this one. When you multiply 22%, so the basic thing is multiply by pi. Alright? Let's proceed. Now that we have a convenient formula for acronym, right? We have known that the acronym is r theta, right? Right. So we can now easily determine the speed of which an object can travel, all right? Transverse any given arc. We have known that from here to here it is
10,005. 10,005 kilometers. We have done this because we have now. They are saying it's very easy for us to find the speed. How the animal, if you are running from here to here, you can calculate the speed of a moving object. If a moving object would like to move from point A to point B, if you have to do that, it's easy to do that. Now, how easy will that be? For instance, if we are told that the ship takes 15 days to make its journey, we can calculate its average speed. Assuming that we are saying that the ship takes 15 days to make its journey, then we can easily calculate the average speed. Let's look at that. What is the formula to find average speed? Let's leave it like that. Let's continue. What is the formula to calculate the average speed?
Distance taken over time.
Average speed is equal to distance covered over distance divided by time, right? At speed, in other words, speed. Speed is equal to distance divided by time. Alright? So, if you want that, so look at this example. What's our distance? 10,005, right? Yes. We wanted to find what will be the speed if one starts from here and then covers this and up to there. What will be the speed like? So distance over time. Speed is equal to distance over time. So here the distance is 10,005. Alright? 10,005. Right? Divided by time. The time taken there, they are saying suppose that the ship takes 15 days. The ship is taking 15 days. Alright? 15 days. The ship is taking 15 what? 15 days. Calculate the speed. Right? So distance not the time. But these are days. Is this time? We have to convert it to time, right? Yes. So time should be 10 5 divided by 1. What's time like? 1 day. How many hours in a day? 24 hours, right? So here, so you want to find 2 hours, right? 24 hours in a day, 1 day, right? So we multiply, find the number of hours here, right? Okay, so 24 multiplied by 15, right? Sure. And the speed will be kilometers per hour. The answer will be kilometer per hour. Alright? So do that. You can easily manipulate that and find that this is approximation 27.8 kilometers per what? Per hour. It's just something more or less like this if you calculate it. Clear? So often information about rate of travel along a circle circumference is given in terms of an angular speed. So what are we doing here? What we are talking about here, this is what's called angular what? Angular speed. So this is the angular speed. The arc length we have seen, arc length is formula for arc length we have said is r theta, right? Yeah. So length is r theta, that is the formula to find the arc length. Alright? But now we can now come up with the formula to find the angular speed. So the angular speed, this is what is called the angular speed here. What is happening here is what's called the angular speed. Alright, now let's define what is this angular speed in terms of what is this rate of someone is traveling in a circumference given the angular speed, which is a measure of an angle transversed over time. Let's define this. Let's go to our definition. Let's define this. Let's go to our definition now. Angular speed and the linear speed. You know what an angular speed is to do with angle, right? The speed over the angle. The linear is to do with a line. Linear and angular. There are two different issues here. Definition. If an object moves along an arc of a circle defined by a central angle, assuming that this is your circle, this is the center, all right? This is the center, all right? And this angle is theta, all right? Something like that. Radius, all right? Assume that an object moves along an arc of a circle defined by the central angle theta in a time t, defined by this angle theta in time t, angle theta in time t. Good. What next? The object is said to have an angular speed. So the object is said to have the angular speed. The object is said to have the angular speed. The angular speed, which is omega. Let's look at that as an omega. So that one is an omega. So this one is an omega. Alright? Omega is given by omega. Omega is equal to theta over time. Omega is equal to theta over time. Alright? Omega is equal to theta over time. But if the circle has radius r, the distance traveled in time 2 is the arc length s. And the radius speed now, if you look at that one, assuming that now this is a circle has a radius r, and the distance traveled in time t as in the angular that s, right? And then the linear speed, in other words, the linear speed that can happen, any linear speed that will happen from here to there, the linear speed is given by the following. So the linear speed is given by, the formula is V is equal to ST. So V is equal to S over T. Which is R theta over T. Which is okay. Good. Let me explain them. This is the formula to find the linear speed. Formula to find the linear speed. V is the velocity. Linear speed is equal to over time. So this is the S is the arc length, right? It's the arc length from here to here. It's our S. That is, it's not the speed. The arc length from here to here is S. The arc length over T. We have already known that what is the arc length formula. The arc length is R theta divided by T. So what we are getting there it is we are getting what is called the linear the distance, the RT, which is the linear speed there. So which is the same as the linear speed, which is the velocity, is the same as the R omega. So the R omega is the same as the velocity of the linear speed, the R omega. So the R, which is what they are saying there is that the R omega is the same as V, which is the same as S over T, which is the same as R theta over T. This where T is time, S is the that, R theta is the remember that S is equal to R theta. An example, let's go to an example that can explain this. An example, suppose finding the angular and the linear speed. Suppose an ant crawls along a rim of a circular glass with radius 2 inch and it transfers the arc indicated in red below in 20 seconds. What are the angular and linear speed of the ant and how far does it travel? Suppose an ant is crawling on a rim of a circular glass with the radius r. It is growing like that. I have seen an ant up there. The radius is r, which is 2. And it transfers the arc length in red below in 20 seconds. What are the angular and the linear speed of the ant? As if you look at from the example 2 that we have already looked at, go to our example 2b where we are looking at angles. We know angle 30 degrees, we know 60 degrees, we know 90 degrees, right angle, and this vertex on the original, which is that must have measure of pi over 3. This means that the theta, from if you want that the theta, they are looking at 30 degrees, they are looking at 60 degrees, they are looking at 90 degrees. Convert those 130 degrees, 60 degrees, and 90 degrees to radians. You can convert that to radians. So when you convert them to radians, let's convert it. What? Already pi over 2 is 90, right? Right. Pi over 6 is what? What is pi over 6? Pi over 2 is 90. Pi over 6? Pi is equal to what? 180 degrees. Right? What is about pi over? Let's go to pi over 6. What about pi over 6? Listen. Alright? Do that? So you take this by the right. So to take pi over 6 divided by pi, alright? Multiplied by 100 what? 8. Right? Therefore, this pi over 6 multiplied by 1 over pi, alright? Yes. Multiplied by 100 what? 8. So 180 divided by 60 or divided by 6, 30 degrees. Therefore, 30 degrees is pi over 6. Alright? So the pi over 6 is 30 degrees. Alright? What about the 60 degrees? What is 60 degrees? 60 degrees. Pi, this one is pi over 6. Pi over 2 is equal to 90. Alright? What about about 2 pi over 3? What will be, in other words, what about 60 degrees? Let's go to 60 degrees. Alright? Pi is equal to 180 degrees. 60 degrees is equal to less, right? So it's going to be this over like that, right? So this is going to be 60 over 180. Is it? Are we? Pi 180 degrees is equal to pi, right? 60 degrees less. Okay? Alright, this is less. So if it is less, this there. 60 over 1 what? 8 times what? Pi. Alright? Okay? 1 here, 3 here. So this gives you pi over 3. Right? Is it pi over 3? 60 degrees. Yeah?
Yeah.
Pi over 3 is 60. Alright? What about 2 pi over 3? What will be that? What will be 2 pi? Should be 2 pi over 3. What is 2 pi over 3? 60. This and this one is what? 360. Eh? Divide by 3. 10 or 120. 120 degrees, huh? Alright, let's proceed. We can now determine the angle shown in the purple. 30 degrees, 60 degrees, and 90 degrees, right now. And this vertex at the origin must be measured, it can be a measure of pi over 3. This means that this angle describes an angle of theta equals pi over 2, pi over 6, and 2 pi over 3. In other words, 30 degrees, 60 degrees, and 90 degrees. So as it works, so its angular speed is omega is equal to theta over time. That formula, omega is equal to theta over time, which is 2 pi over 3. Alright? So, right, yeah. I think we got confused. Can we go back again? Can we go back again? Eh? Let's start from the formula here. What was the formula? What was the formula like? Alright? What was the formula? To find the theta. According to that one, the theta, they are saying, we suppose, so they are talking about that we can describe that one in the 3 angles, assuming that we are using the 3 angles, which is 30, 60, and 90. Alright? Because obvious that this and has to go through 30 degrees, has to go through 60 degrees, has to go through 90 degrees. All these angles, I think it has to go through that. Therefore, they're saying, let's now calculate, let's convert these ones into radians, and then we use the formula of omega. We have to use the formula of omega here. I have to use this formula of omega here to find the linear that. Now, we're saying angle 90, angle 30, these are the standard angles. Another angle 60, another angle 90. Of course, they must be in the angle 45. Alright? because it is standing up on the first jump. We jump right in. We look at that. What is this angle 30? Angle 30 in radius, what is it? 30 degrees. 1 degree is 180 degrees is equal to 5, alright? Right? What about 30? 30 degrees is equal to 30 over 1 what? 80 times 5. Right? Alright? 1 here, 6. So this gives you 5 over what? 6. For number 1. Let's reserve this one. 60 is going to be 60 over 180 times 5, alright? Which is 5 over 3, right? Sure. 5 over what? 3. Let's reserve that. 90 over 100 what? 80 multiplied by 5. And this gives you 5 over what? 5 over 2. This standard ones are these ones. If you do this for 5 would have been what? 45 over 180 times what? 5. Right? So this one would have been 4. So this is going to be 5 over what? 5 over 4. More what? Radius. Now, they are saying if from example 2b, from example 2b, to go to example 2b, they are saying that we had to find these angles so that you can revise example 2b based on this inside there is what's called pi over 6, pi over 3, and pi over 2 triangle. I think we can go into that, find the type. Now when you look at this one, they are saying that to find the angle of that theta, because it has got these 3 angles, the angle of that theta, because it has 30 degrees, 60 minus the talk about 30 minus 60, it means that you are going into anti-clockwise. That's why it's going minus. You want that one, but the angles to be the same. It's going to be positive, the same positive. The radians will be the same positive. You don't have the negative. That's why you describe that angle theta, you add pi over 2 plus pi over 3 plus 2, pi over 2 plus pi over 6, pi over 2 plus pi over 6. So the pi over 2 is 9, right? Pi over 2 plus pi over. Why have they taken pi over 2 and pi over 6? Why have they taken 30 degrees and 90 degrees? Why have they taken 30 degrees and the other what? 30 degrees and 90 degrees? Because what they are saying is pi over 2, the theta, if you look at what is happening there, 90 is fine, because pi over 2 is 10, because they are doing 90 is fine. But pi over 6, which is 30 degrees. 30 degrees, which is pi over 2 plus pi over 6, and it gives you 2 pi over 3 as it works in the angular speed. So the angular speed as it works, so its angular speed is omega is equal to theta over time. So the theta, it is 2 pi over 3 over time is 20 seconds. According to what they are giving this 20 seconds. So 2 pi over 3 divided by 20 seconds, they are talking about that gives you pi over 30 radians a second. But given that the radius of the angle is 2 inch, the radius speed of the ant V is equal to R omega is equal to 2 times the 2 inch times pi over 30, the radians, which is pi over 15, which is approximation 0.21. Finally, the distance the ant travel in S, which is R theta, is 2 times 2 pi over 3, which is 4 pi over 3, which is 4 pi over 3. I think what you have to do is, when you go, can you revisit that area and then, so that maybe you can again look what is happening there about the angular speed and the linear speed. So I think we'll go back to that. Now, let's look at another issue, which is let's go to an area of a circular sector. Let's go to that. I think that is very interesting. The area of a circular sector. All right, the area of the circular sector. I think from this example 4, what you have to do is they are considering 90 degrees and they are considering 30 degrees, 90 and 30. Knowing that maybe starting point of the standard angle is 930 and then the ending point is 90. Change to radians is 2 pi over 3. So that one divided by 20, the time there, you are getting the omega, which is omega is equal to the theta over the time. And when you look at that, so to find the R omega, so you are applying, which is the R is the radius. The radius is that one which is from there to there, where is 2. So 2 times R over 30, and that will get the answer. So 2 times R over 30 give the answer, which is the pi over 15. Right? Finally, the distance the ant travel in R theta is 2 times 2 pi over 3. The 2 pi over 3, which is 4 pi over 3. Alright, let's go to area of a circular section. We'll finish our discussions this morning from there. Let's go to area of the circular section. From that, I think I will tell you what you have to do with the other part, because I want to start trigonometry calculus. So I think for the 2-3 consecutive days that we are basing up the last one, we will go to calculus. Now let's go to this issue on what is called the area of the circular section. Let's go to area of the circular section. Let's finish off area of the circular section. Area of a circular section. Area of a circular sector. That's what we are wanting now. Area of a circular sector. All right. What has to be in your head? You have to know what area of a circle. You know about area of a circle from this MSc point of view, right? area of a circle is equal to pi r is equal to what? Area of a circle pi r squared. You remember that? Huh? Area of a circle. Alright? How do we get area of a circle? What? Area of a circle. Huh? Area of a circle is equal to pi r squared. Okay, that one. Alright? Area of a circle is pi r squared. You agree?
Yes.
Hmm?
Yes.
Now, let's go to area of a circular sector. What about area of a circular sector? It is alright. What to look at this one with the example of measured radius. By the way, what is a sector? Let's define what a sector is. What is a sector? Which is our S. What is a sector? It's a part of a circle, right? It's a portion of a circle. A sector is just a portion of a circle, right? Like if I do like this, this is the center. This is the sector. What about this one? Again, this is the sector, right? Yeah, this is the major sector, and this is the major sector, and this is the minor sector. Alright? Then, if it is an arc, you have an arc here. Minor arc, and this one, major arc. You know that, right? Right? So, it's minor sector, major one is the bigger sector. Alright? So, a sector, we can define a sector as a portion. A portion is the same as a part or fraction. Alright? Fraction of a circular object is a sector. Fraction of a circular object is a sector. Right now, a sector of a circle is just a portion of a circle between two radii. So if you add this one, this is the center. How many radius are there? So this is the radius. This is the radius. A, B, C. Let's put A before center. So our first radius is AO is a radius, right? This is the radius. And the CO is again what? Radius. Alright? Together we call them radii. Alright? Then the area of a sector they can range from 0 to pi r squared. Therefore, the area of a circle, can range from 0 to what? Area of a circle is pi r squared. So can range from 0 to pi r squared. In other words, area of a circle, it ranges from 0 to pi r squared. Alright, we'll look at that. Where the radius of the circle is assumed to be r unit. Radius, you know that radius is r unit. Of course, the two radii defining a given center can also be taken to be the initial and terminal side of the central angle theta. Therefore, even if you have got this is the center. The central angle theta is this one. This is the central angle theta. Because this theta is being defined by this radius, this radii, this one and this one. So this is the theta here. But because this is a sector, it is the theta divided by 2 what? Because we know that sector is equal to theta divided by 2 what? 2 pi. Hey, over here, from what we have seen previously. What? This is what we have